X equal to answer. Yeah. But you have to find the full answer. So you do estimation. You do estimation and find out where your answer will lie. Then you solve this problem. Yeah. X will lie between 1 and 7 by 6 is that right? Estimation.
7 by 5.
7 by
5.
let's see. Hey. This tells you that. And what does this tell you? Okay, sorry, you are right. X is between 7 by so 1 to. Is this correct? Seven by five is how much? 1.4. No? 1.4. Now we'll solve it. Good. Now we'll solve this problem. So how will we solve? See, this is another style.
So if we put 1 by 4, sorry, 1.4, then the other, this will become 4 and that will become 2. 2 plus 4 is 6. Not satisfied.
No, this is estimation. That means your answer will lie between these two numbers. This is not answer. Estimation is not answer. Estimation is just to encourage you, go ahead. You don't have to bother about all numbers under the sun. Just numbers from 1 to 1.4, which is an easy job. Now let us do this. See this. So if you put x equal to n plus q, okay? Now you see this, hello. Now this 2n plus 2q will be 2n or 2n plus 1. It will depend on whether q is less than half or greater than half. Suppose you say q is 0.6. If q is 0.6, this will be 2n plus 1. Now, interior part will be 2n plus 1. And if q is 0.4, it will be 2n. Similarly, this. So, what is going to matter is q. The interval of q is what? From 0 to 1 will be divided in this. Because of these numbers 2 and 3, the domain of q, which is 0 to 1, will be divided into 0 to 1 by 3, 1 by 3 to half, half to 2 by 3, 3 by 2 to, then 3 by 2 goes out. So these are the intervals. So you will have to consider how many intervals. So let us see first interval. Q is between 1 by, Q is less than 1 by Hello, see this. This problem may become lengthy. If it is INMO, maybe INMO's so more interesting problem is asked. So first you do estimation and then do. So what? Now let us see this. If Q is less than 1 by 3, so this will be 2n. Is this correct?
Yes.
And this will be 3n.
That's it.
So n will be equal to what? So what will be the answer in this? So n is 1, n is integer, yeah, this is good, welcome. So what will be the answer?
1 to 1 point.
1 to 4 by 3.
Yeah.
Yeah, so see this. So this n is 1 and q is this now.
1.3.
So add 1. So x is less than 4 by 3 and greater than equal to 1. This is the answer. And this answer is within the estimation. This each and every number from this interval will satisfy this equation. Right? So what will happen? 4 by 3 is 1.33 now. 1.3 will satisfy this, 1.34 will not. Check. The solution will be 1.3 is the solution. But 1.34 will not be solution. And you see how close is your estimation. This encourages you to stop here. There won't be, you need not consider this interval, there won't be any solution. And when, if you go to this interval, yeah, let us see. Suppose let us go to this interval. Yeah, let us come to this interval. So what? Q is less than half. So what will happen? This will be 2n plus 1. Will it be? No. Suppose you take a typical number here, 0.4. So it will not be here. This will be 2n only. But this will be 3n plus 1. Because this will become what? 1.2. So taking a typical number is a good idea. Should we accept n equal to 4 by 5? No, we have pledged that n is integer. So stop. That's it. So the intervals are like this. See, because 2x and 3x, na? So 0 to 1 will be divided into 1 upon 3, 1 upon 2. Suppose it is 3 to 5. Suppose this is 3. Correct? So what will happen? It will matter whether q is less than 1 by 3 or greater than 1 by 3. So this will be this 1 by 5, 1 by 3, 3 by 5, and 5 by 3 will go out. So these will be them. Correct? So this. So first we did estimation and then. Okay, once this RMO asked it, in RMO the problem was longish, but I'll tell you a simpler. Find all solutions of this. Okay? Find all positive integer solutions of this. Okay? So, this problem can be done like this. Let this be equal to 0. What are the possible values of x? X should be 0, 1. Yeah, if I say this whole thing is 0, what are the possibilities of x? X will be 0. X can be 1. Can it be 2? No, because this will become 1, this will become 2. So that means 2 solutions are possible. Then we say this is 1. How many solutions are possible? X equal to 2 is not possible. Correct? But this will be 1 and this will be 0. 3 is possible? Yes. 4 is possible? No. This will become 2 and this will become. So, can there be some other way? Yeah. 4. I mean, so then next we will say this is 2. So, what are the solutions? 4, I mean, 4. X equal to 4 will be a solution? No. X equal to 5 will be a solution? Yeah. And x equal to 6 will be a solution?
No.
No. So only solutions are 0, 1 and 3. So this problem is done like this. And once in RMO they ask this question. And you can go on doing like this, you will see a pattern of solutions. The number of solutions they were making it arithmetic progression. And the total number of solutions were 2,500. Total number of positive solution, integer solutions were 2,500. For example, here there are 3. And just let me tell you, estimation. Suppose you do estimation. So what will happen? I mean, why don't we go ahead with larger numbers? For this, the estimation will stop us, discourage us, let us. But estimation is difficult here in this problem. This is why it is difficult? Because of inequations. Inequations, hello? Just you sleep, you read whatever, you go out. Oh, this is the okay. You alone you do whatever you can. Yeah. Estimation. In this case, estimation. The home work. How many? Okay, you do it later. Okay, now see this. Yeah, one very educated thing about inequations will come out. Now you have to subtract. You have to, because the equation is like that, subtract. So this will be what? And you can subtract inequations. Very important property of inequations is, suppose A is greater than B and C is greater than D. You can always add them. Correct? And if you want to take added term here, it will be subtracted. If you want to take subtracted term here, other side, it will be added. You can always add two given inequalities in same direction. But you can never subtract. Never subtract. Because subtraction is non-commutative. Suppose you are subtracting equation 1 from 2, so you are subtracting 1 from 2 or 2 from 1. Addition is okay, 1 and 2 there. So if you subtract 1 from 2 and then 2 from 1, there both the results will be opposite. So it is spurious, it is wrong to subtract two inequations. You should never ever subtract two inequations. Correct? Similarly, so if all sides are positive, then you can multiply. You cannot subtract two inequations. You can never subtract two inequations. You can never divide two inequations. This is also not committed. Using 1 from 2 or 2 from 1. And you will do one, when you do other, you will be completing. If there are two inequations, you want to use them, write them in same direction and add whatever you are getting, be happy with that. And if all sides are positive, you can multiply. And you will get, if you subtract or if you divide, you get wrong result. Now here what will happen is, so that is why I am not subtracting. That is why I am not subtracting like I was adding. So what you should do, that is very interesting. You take this and you take this. write them in same direction and add. You'll get something useful. What? Write them in same direction without changing the meaning. Huh? This is what is meant by write them in same direction. Correct? So what will happen? Since your equation is this and this will get cancelled, now add. What you will get? X by 3 minus 1. So this will be what? This you can take it here. So x by 3 minus x by 2 less than 1. So this will be what? 2x minus 3x upon 6. Correct? This will be minus x upon 6. So x will be greater than minus 6. Now next time what you do is to write them in same direction and add and do something like this. So what you are going to get is, to estimation theory will say that x will lie between minus 6 and 6. Okay? Minus 6 and 6. And since you were asked positive integers, forget about minus 6. You can say 0 to 6. That is why your answers were what? 0, 1 and 3 you stop. I mean, you are done. We have gone to 5 and 6 now. This answers why x was equal to 0, 1 and 3. That's all. Yeah, now you ask me. Yeah.
What did you cancel the x by 2?
Oh, yeah, this is because of this. We are solving a question. We are given, huh? I mean, to add this, when you add this with this, yeah, the difference is that. Not the point. I mean, I can write like this. Huh? I can say this and this. It's a very serious thing. You cannot subtract two inequalities. For example, this. So f and f prime are fractions. Okay? F and f prime are, but f plus f prime is a integer. So what will be the value of f plus f prime? If f lies between 0 and 1 and what f prime lies between 0 and 1. If f plus f prime is an integer, what will be the value of that integer? 1. Great answer. Why? You can add them. You can add them now. They're simple. So you can say this f plus f prime. And since you are saying this is integer, it has to be 1. Now, if f is between 0 and 1 and f prime is between 0 and you are told f minus f prime is an integer, then what will be the value of f minus f prime? 0. Very good. So why it will be 0? You see this. We will take this and we will take this and add them. We will get f minus f prime equal to 0. See this. F is less than 1 and what f prime is. Correct? So this will be what? F. Correct? So f minus f prime. And you are told if f minus f prime is an integer, what will it be? It comes from here. So what? We cannot subtract them this thing. So all this I am telling you is given two equations, write them in same direction and add. It will be correct. And you cannot subtract them. Similarly, you cannot divide them. Okay? So here this was the estimated answer. And what in equations, many times students what they do is this. A is greater than B and A is greater than C. Oh yes, B is greater than C. It's correct?
No, sir.
Now you are saying no, but in the pressure of examination, you will say, "Ah, this is what is this answer?" And A, B, C will not be A, B, C, there is some accuracy. So say, I this is this. And you will come up and say, I will solve that equation problem, inequality problem. No. So what? When I ask you like this sounds absurd. But in the examination, all this will not sound absurd. So be careful, right? Then, suppose you want to do this, A is greater than B and C is less than B. Suppose you want to use them, the best way is write them in the same direction and add. Be happy with whatever you are getting. So what you do, you write it as in same direction. That means you write this C and this B and add. You can do many things. You can multiply by 3 and add many other things. Correct? But you cannot subtract them. Correct? So this. And one more thing. When you're solving inequalities, this means what? This means A is greater than C, B is greater than D, and all that. This is correct. If you are going in the same direction, it's okay. But suddenly, suppose you get this. This is absurd. You cannot conclude anything from it. You cannot say A is less than M. So if you are going in this direction, suddenly you change the direction. This statement becomes absurd, useless. You cannot say. So that means whatever you will conclude may be true, may not be true. In maths, we don't say that you do this, you may be true, may not be true. So we leave this, we don't do this. Correct? Now we will do one problem where these things will be very clear to you. What? How to calculate inequalities. So if x, y, z are like this, so you have to find this will be less than what and greater than what will be the lower and upper bounds of this. Okay? So now let us do this. This is called estimation, another type of estimation, or x is greater than this. So I can write this now. Is this correct?
Yes.
And I can write this.
Yes.
If provided this. Correct? I can write this. Is this correct?
Yes.
And I can write this. Is this correct?
Yes.
You have to prove this. Do it that. Yes, you need a division, but and this question was asked in ITJ once when the exam was descriptive. The examiner was going to see whether if you divide two inequations, you will get 0. Because what happens is when you divide or when you subtract two equations, sometimes you get correct result. Sometimes. And you feel very happy. But it is supposed to be spurious, it is supposed to be suicidal. You get 0 marks or negative. Okay? So don't do this. So what? If you want to go get this, so what you do is you want this now. So you write two equations in same direction. So this and maybe this. I mean, don't write x equation this and this in same direction. And multiply. Whatever you get will be correct. Okay, so what? You write this. Correct? And same direction. So this. So this. And this will be what? Now multiply. Why you can multiply? Because all of them are positive. So if you multiply, this will be what? and this will be correct. And 3 cancel. Now what? You want this line? You can bring it here. The positive quantity, you can sign of the equation will not change, and you can bring it here. So what you are getting? You have not divided, you have multiplied. And after multiplying, we are doing normal notation. You can bring that up here and then because they are all positive without changing the sign of equation. Now, if you write these two in same direction and multiply, you will get this. Okay. So these are the bounds, upper bound and lower bound. These are the equations, correct? Yeah, I tell you a joke. You know, this mathematical sense is not very common. You should investigate this in your surrounding, in your family and around. Okay? This mathematical sense is not common. So right from beginning, when children are told algebra, most of the children, they don't understand why this x plus x is 2x. Why not x square? Why 2x square? So you ask them, x plus x, 2x. 2x? No, 2x, x square. X square? No, 2x square. Put it students, x plus x, 2x. 2x. X plus x is 2x. 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 They don't. You are the ones who say 2x. Always. And they, sometimes they say 2x. X square, 2x square. And then calculations are very interesting. So they are very poor ones and they don't understand algebra. So they don't have common sense to understand algebra. Even elderly people do this. For example, I mean, if you ask them, general, they maybe most of the people around you are scientists and also. But if they're not scientists or they don't have science, they say, what is this? It makes common sense. No? And then what you say, A plus B, A square plus B square. Correct? Now our Prime Minister Modi somehow is different. So he knows that A plus B square is and in abroad and in India, 3-4 places, abroad 2-3 places, he said this when you square A plus B, you get one extra term. But he is at least better off. He at least knows that you get 3 terms. So he says you get extra term, and he has said this here, and he said this is abroad, maybe others also. No extra term, not illegal term. Why he says that? Because he finds and he must have himself thought, okay, actually A square plus B square is right. This is inconvenient. But he must have heard that this is right also. He calls it extra. But in NCERT books, I'm not surprised if next year onwards or this year, when they may start calling it extra, or they may even call it Modi term. Why? Because common sense is very poor. Mathematical sense is very poor. Once the teacher checked answer sheets out of 20, English teacher. So the principal said, no, actually you should check it out of 25. She said, okay. He comes back to the staff room and she gave 5 marks to each. And she was thinking she did it right. Just for this thing check, she asked her friend, it's okay, na? Yeah, I did 5 marks. Okay, this seems to be looks good. Then this joke came to me. I said, what? 5 marks within immediately I sat down to see what. So what? If you give 5 marks to everybody, everybody got benefited, or some got benefited, some got what happened? If she gave, huh? In general, everybody got benefited. The one chap who got full marks, you know what? Okay, so basically what she should have done is she should have scaled it, na? She should have scaled the number up by 4 factor, right? And she gave 5 marks. So the fellow who got, got 0 marks, he got benefited most, right? And it was totally illogical. Then I said, hey, what? This is a joke. I sat down to work, and that was the time when I was not able to solve one inequality problem. Um, it was 1990 or something. Nowadays, a lot of it is published, and here it was not published. So there was one inequality problem in a triangle. Trying to prove this. So I proved this. This I was not able to prove. And you don't do that. We didn't have friends to discuss these problems and all. To do this problem and solution is not possible. Then I realized that day that teacher has created an inequality. How? So that inequality I say is this. If a upon b is less than 1, that is a upon b is a proper fraction, then a upon b will be less than a and b are positive, x is positive. Is this correct? Hmm? Correct, na? So then I created this new result out of this joke and this. So then I thought I can solve this problem. In a triangle. That is, in any triangle, if you calculate this object, it will lie between 2 and 3 by 2. Any triangle. Can you prove this? This is the left hand side. Oh, right hand side. This is crucial. That day I could prove this problem. So can you prove? I'm giving you the hint. So see this. In order to, now there is an essence. Yeah. So like I told you, they don't ask you to do it. They don't ask you complex numbers. They don't ask you logarithms in Olympiads. But when they ask you this, the little essence of those things is used. That's very dangerous. You may have solved a lot of logarithms. But they will require something which actually checks some essence of logarithm, some essence of trigonometry, triangle, and or complex numbers. And when you are generating a lot of these complex numbers, so many things are you have a lot of problems. But the essence remains. The essence remains. So what is that essence? Okay, so just so what if you want to apply this to a ratio? That ratio should be less than 1. The ratio should be, and what are the ratios here? A upon b plus c, and we know that the essence of triangle is sum of two sides should be greater than third. This is a great essence of trigonometry which Olympiad uses. No sin theta, cos theta, and all. So if it is a triangle, or say A will be, is B plus C will be greater than A. Correct, na? So what will happen? This means is correct. So this ratio will be less than 1, this ratio will be less than 1, and this ratio will be less than 1. So I can apply this. How? So see this. If I call this as f, so f will be what? Less than a plus a, b plus. That means in this ratio I will add a up and down. Correct? And in this ratio I will add b up and down. And in this ratio I will add c up and down. Have I solved this problem?
Yes, sir.
Oh, I was the happiest person. That after hearing this joke, I could solve this. Then I presented out problems based on this. And I don't really know what was the original solution of the Olympiad problem, but because when these problems are nowadays, a lot of it is published. So official solutions are also good. So I don't know what was the official solution. But this looks good now. And that joke also, if you remember this inequality by the two. Correct? You can have four counterparts of this. When a plus b, when you subtract a plus a upon b is less than or subtract x up and down, then you get a lesser fraction. So there are four versions, but this is the best. If a upon b is less than 1, you add something up and down, then you get a bigger fraction. Correct? Next question. Prove that this is less than 1 upon 10. How will you prove? This joke has to be used again in order to prove this. Yeah, any idea what should we do?
We can add, we can add bottom term with 98 first term and above also 98.
Okay, if we say this is P,
Yes.
then Q will be what? That means add 1 up and down, up and down, up and down. Correct? That we call Q. So this will be what? 6 upon 7, this will be 8 upon 9, and this will go up to what? Yeah, 100 upon. So what? By this theorem, we will say P is less than Q. Is this correct? Because Q has been obtained by adding 1 up and down. So we get a bigger fraction. So P will be less than Q. Is this correct? Now what we'll do, we'll multiply it by P both sides. So what will be PQ? Yeah, so P square is less than. So have you proved it?
Yes, sir.
P will be less than 1 upon 10. Correct? So in equations, inequalities, they are called inequalities. Earlier we were doing inequations. Inequalities, they are valid, they are like identities. They are valid for large number of what? Large set of numbers. Okay? So yeah, let me do this. This called Nesbit's inequality. The right hand side is called, it has got lots of groups. 10, 12, 13, 14. Okay? But one simple, the simplest proof I'll tell you. Okay? So, what I will do, I'll add 3 both sides. I'll add 1 to each of them. Correct? So, if you add 1 to each of them, so you get this. Plus what?
A plus B plus C upon C plus
Correct? So, this will get. Okay? Yeah, look at this. So, look this. Yeah, check this. If you multiply, do we get this? Then this. Then this. Is this correct? Okay. Now next. So this will be is this correct? Next, what should we do? We will use AMGM. So what is AMGM? AMGM is this P plus Q. Arithmetic mean is greater than geometric. When
X and Y are positive.
P and Q. P and Q are positive. Okay, very good. And here we are talking about triangles and their sides of a triangle, they are all positive. You don't have to worry about it. So what we have got a great result. This is 2, this is 2, no? Arithmetic mean of this is this, and geometric mean will be what? 1?
Yes, sir.
This is 2, this is 2, this is 2. So, this is what? This is 9, and this is a great result. This is called AMHM inequality for 3 variables. Why? Because you can write it as x plus y plus z upon 3, which is greater than 3 upon 1 upon x plus. This is AM, this is BHM. Okay. But why did we record it here? We want, we can say this x, this y, this is z, so this will be greater than what? So here you can, what we are going to utilize is this. AMHM is written in this form, this. Correct? Can we use it here? So 1 upon x plus 1 upon y plus 1 upon z will be what? 9 upon. So this will be greater than 9 upon this plus this plus this. Is that right? Is this correct? So what? F plus 3 is this correct? We got inverses. That is why I have to use this. Correct? 1 upon x plus 1 upon y plus 1 upon z is greater than equal to 9 upon x plus y plus z. We have proved this. This is called Nesbit's inequality. Okay? Any question? Yeah?
So is this P2's lemma? That one.
Very good. If you can solve a problem without naming any big name, you know that. If you are naming, you are scaring people and the teacher is scaring you. What do you mean? We are doing that, sir. Don't name them. This is our system. Here, this is our classwork. And examiners like it if you don't use any big name and solve your problem. Right? No T2 lemma. So this. Okay? This is called AMHM inequality. I didn't say this is Zafar lemma. The AMHM. Correct? So this. So this is just proof. If you solve your problem without naming any mathematician, especially inequalities, examiners look at you with respect. Oh, there's T2 lemma, T2 lemma. And if you use the T2 lemma, now please see to it that you solve, prove that. Otherwise, you will not get full marks. If you have used somebody's lemma, then you have to prove that. Yeah, so this. Okay. Now let us see whose lemma you will use for this problem. Yeah, there are beautiful things, but everything cannot be discussed. So, yeah, that's good. Yeah, tell me this. I have this. What does it mean? X and Y are satisfying this. AM is less than G.
Like, sir, x is equal to, sir, only equality is possible in this case.
This is called essence. Don't look for. Okay, so what is the essence? Now it will turn out whether you know AMGM. AMGM has become very popular after Olympiad. Earlier nobody had heard its name. So at least AMGM is known and something. But the essence is missing. What is this? And what is what does it mean? I have X and Y which satisfy this. What does it mean? Yeah. Very good. They are negative. Very good. What else?
X equal to.
No, what else? This one sentence. When X and Y are negative, it will be this. AM will be less than P. When both of them are negative. What else? X and Y. When else this will happen? Generally, AM is greater than GM, no? when x and y are positive. But when x and y are negative, this statement is not made. That is the problem. But you can make. No, no. Like x and y, she said are negative. Now, what is another possibility? What is it? So see this, the correct statement of AMGM is if quantities P, Q, R or two quantities, three quantities, they are real and positive, then AM is greater than GM. And if they are not real or if they are not positive, no statement happens. That means you explode yourself. Correct? So then I find if it is binary inequality and AM is less than GM, then X and Y are negative, both negative or both complex conjugate. Means X is and Y is check. Put this here and check whether it is correct. Is correct? No? See this. So this will be what? X plus Y, so this will be alpha, and this will be what? Is correct now? So, this is a very interesting point. If AM of two quantities is less than GM, if AM is less than for two quantities AM is less than GM, what is happening? Both the quantities are negative or both the quantities are complex conjugate. But this statement unfortunately cannot be extended. It is true for two numbers. Now you see this. When we say, you know this omega, cube root of unity. So what I can prove, see this, what I am trying to say is, mathematics makes a statement which cannot be repeated. Right? So what it says, if numbers are real and positive, A is greater than G. Now I say, if I take complex numbers, then what will happen? So what does mathematics say for complex number?
Complex number doesn't like equality.
No. What happens? Yeah, right. But maybe your in between they are complex, but left hand side and right hand side are real. So I'll show you. So what I am going to show you is that three complex numbers of both sides. But mathematics doesn't make this. This is my own play of this thing. That is just a local. Mathematics makes a large statement which cannot be repeated. A small statement you can enjoy yourself. Yes? But this in two dimensions, this statement is very good. That both the quantities are negative or both the quantities are complex conjugate. Then A will be less than GM. Now I'll just show you that these numbers cube root of unity. So their arithmetic mean is what? Correct? And the geometric mean is what? Those of you who know this now. Is this correct? So what? There's an identity omega square plus omega is minus 1. So put that and check whether now you see your point. See, omegas are complex, but the net right hand side and the net left hand side they are real. So they deserve to be an inequality. So is this true? So this will be what? This plus this. So this is 7 upon 3 is greater than 2. So 7 is greater than, it's correct now. Yeah. So this is correct. This is our local entertainment. You can enjoy this, but you cannot do the who has already been said by mathematics. If numbers are real and positive, M is greater than GM. Your numbers are complex. Why the hell you are talking about M GM? If you are talking about it, just by yourself. Right? So mathematics makes a large statement. And if you ask, if suppose if I take complex number, mathematicians are not ashamed of saying, no. You say, I don't know. Check, you see. Okay, this is your problem. You are going against the statement. You check and see. And your mathematician knows this. So I am not. Maybe he chooses complex numbers and left and right hand side are not real. So he defeated himself. He'll make a fool of himself. Huh? So, but what I'm saying, mathematics makes a large statement. Okay? So, where everything, 2 dimension, 3 dimension, 4 dimension. But I happen to segregate them. 2-dimensional is something more than we said. AM is less than GM, so both the numbers are negative, or both the numbers are complex number. So this has not been said, so we can enjoy, we can entertain ourselves. That's it. That's a good general thing. But in general, you're talking about AMGM, you have to be having positive, real positive numbers. And whenever something is claimed for a set of numbers, for other things, what will happen? And conditions decide to do different things, you put them and check what happens. But the statement is this, that you cannot defeat. If you take real positive numbers, A will always be getting. You cannot find any more in that. So it is called they are true in one direction. If positive, real and positive number, yeah, this is very good thing for examination. Examiners. If numbers are real and positive, then M is greater than GM. If M is greater than GM, it doesn't mean that numbers are real and positive. Converse may or may not be true. This is the whole thing of A and B. If quantities are real and positive, AM is greater than G. If AM is greater than GM, it is not necessary that the quantities are real and positive. Very important. So if AM is greater than GM, you cannot claim that the quantities are real and positive. If quantities are real and positive, you can claim that AM is greater than GM. So this is called converse may or may not be. This is never looked at. But as a student and examiner, teacher, when AM is taught, it should also be said, if AM is greater than GM, it doesn't mean, it is not necessary that numbers are real and positive. If numbers are real and positive, AM is greater than G. That means you can construct examples where the numbers will not be real and positive, AM will be greater than G. But there is no rule. Okay, so with this we end. And in case you want to react, ask questions or something, you can use my WhatsApp number. And this is my email. Okay, this is dash hyphen. It is not understood. Okay. Sorry, we didn't have much time, and whatever was possible I have discussed. And so other things you can ask me on email or doubts or questions you can ask. Okay, wish you all the